You think black holes suck. Not metaphorically, literally. You picture a cosmic drain, pulling in stars, planets, light, common sense, anything unlucky enough to wander nearby. That image didn't come from physics. It came from movies and animations. And the quiet assumption that more gravity means more pulling. That sounds right. It isn't. If the sun were magically replaced by a black hole with the same mass, Earth would keep orbiting exactly the same way. Same distance, same speed, same year, no dramatic spiral, no sudden doom, no cosmic slurping. You are told black holes are violent eaters. They're not. They're accountants. Gravity doesn't reach out, it doesn't grab, it doesn't hunt. It just sits there, enforcing geometry. That's the first intuition you have to lose. Sci-fi teaches you gravity is a force, like a rope pulling you inward. Physics says it's not a pull at all. It's a rule. Mass tells space how to curve, and curved space tells matter how to move. No hunger required. You don't fall into gravity. You follow the shape of space you're already in. NASA didn't figure this out by imagining it harder. They watched stars orbit something invisible at the center of our galaxy. Fast, clean, precise orbits. No drag, no suction, just motion responding to mass. Radio telescopes confirmed it. X-ray emissions confirmed it. Eventually, even light itself traced the outline. And when we finally saw a black hole, notice what was missing. No funnel, no vortex, no visual evidence of sucking. Just darkness, surrounded by glowing matter moving exactly as the equations predicted. Which brings us to the phrase everyone repeats without understanding: nothing escapes a black hole. You hear that and imagine a force so strong it grabs light like a hand. That's wrong again. Light isn't being pulled back. There's just no path forward that leads out. This isn't about strength, it's about direction. Near a black hole, space bends so severely that every possible future points inward. Light still moves at the same speed it always does, it just runs out of options. You wouldn't feel yourself cross that boundary. No alarms, no stretch, no cosmic snap. According to your own clock, everything seems fine. That's the part your intuition hates the most: catastrophe without sensation. And now we pivot, because this is where Einstein enters the story, not as a hero, but as a man who didn't fully trust his own work. Einstein gave us the modern understanding of gravity. He replaced force with geometry. Space and time fused into a single fabric that could bend, stretch, and distort. It explained Mercury's orbit. It predicted gravitational lensing. Every test thrown at it passed. Well, because hidden inside his equations was something he didn't like. They allowed for regions where curvature became infinite, where space folded so aggressively that the math stopped behaving. Not hard to calculate, nonsensical. Einstein didn't celebrate that. He resisted it, publicly. He assumed nature wouldn't be so crude as to produce infinities. Surely the universe would avoid such embarrassment. The universe did not cooperate. Decades later, observations forced the issue. Stars orbiting nothing. Galaxies ejecting jets of energy from invisible cores. Timing measurements so precise they left no room for interpretation. Whatever these objects were, they weren't theoretical accidents. They were real. The equation didn't break because it was wrong. It broke because it was honest. Singularities aren't objects you can point to. They're warning signs. They tell you your framework has reached its limit. Physics treats infinities the way engineers treat cracks, as evidence that something deeper is missing. And that's the uncomfortable truth people skip. Black holes aren't where physics is strongest. They're where it admits ignorance. NASA doesn't send probes to black holes expecting answers. They send telescopes because even observation becomes dangerous to interpretation. Time itself starts misbehaving. Clocks don't agree. Cause and effect lose their familiar order. Near massive objects, time slows. Not as a metaphor, not as a feeling, as a measurement. Atomic clocks on satellites tick differently than ones on Earth. That's not philosophy, it's engineering. GPS systems correct for it every day, or your phone would think you're miles from where you actually are. Gravity at its time. Let that sit for a second. You assume time is universal, flowing the same everywhere, like background music. Physics says it's local, adjustable, sensitive to mass and speed. The heavier the environment, the more time resists moving forward. Black holes don't just trap matter, they trap futures. And none of this was discovered by intuition. Every step forward happened because data embarrassed a belief, because measurement contradicted imagination. That's the pattern you need to notice. Your confidence about space doesn't come from understanding. It comes from stories that feel right. Circular ideas, visual metaphors that collapse the moment you ask them to survive math. Space is not obliged to match your expectations. It isn't designed to be understood casually. Black holes don't suck. Einstein didn't finish gravity, and the universe does not care how convincing your mental image feels. This isn't trivia. It's a demolition. Because once you accept that gravity is geometry, that time is flexible, and that even our best equations can predict their own failure, the ground you're standing on intellectually starts to bend. And that bending doesn't stop at black holes. It scales. You think your intuition scales, that if you understand gravity on Earth, you just need more of it to understand the cosmos. That's a comforting lie. Your intuition evolved to throw rocks, not to survive curved space-time. On Earth, gravity feels simple because the planet is slow, massive, and polite. Time differences are tiny. Space looks flat. Everything behaves well enough that Newton still works. You mistake that convenience for truth. Now, zoom out. Imagine two identical clocks. Same design, same precision. One stays on Earth, the other rides a satellite. NASA has run this experiment, not once, constantly. They don't agree. The satellite clock ticks faster. Not because it's broken, not because engineers missed something, because gravity is weaker up there, and weaker gravity means time loosens its grip. That's not interpretation, that's measurement. If GPS engineers ignored this, your navigation would drift kilometers per day. Reality would literally mislocate you. So here's the correction you didn't ask for. Time is not universal. It never was. You don't move through time the way you think you do. You experience time locally, stitched to your path through space. Change the path, speed it up, deaden the gravity, and time responds. This is where intuition fails catastrophically. You assume time flows forward because it always has for you. Physics doesn't say time flows. It says events are ordered differently depending on how space-time is curved. Before and after are not global agreements. They're negotiated locally. Now escalate the scale. Picture a planet much denser than Earth. Same size. More mass. Stand on its surface and your weight increases. Sure, but something stranger happens quietly. Your clock slows compared to Earth's. Your biology doesn't notice. Chemistry still works. But relative to the rest of the universe, you're aging differently. No sensation, no warning, just divergence. This isn't science fiction. It's what equations demand and experiments confirm. You think of gravity as something objects have. Physics treats gravity as something space-time does. That difference matters. Because once gravity becomes geometry, motion becomes destiny. You're not pulled along paths, you're constrained to them, like a train following tracks it cannot see. And now introduce speed. The faster you move through space, the slower you move through time. Not metaphorically, mathematically, tested with particle accelerators. Muons, created in Earth's atmosphere, should decay before reaching the ground. They don't, because at high speed, time stretches. Your intuition screens that speed and time are unrelated. Reality disagrees. This is where people usually try to compromise. Okay, they say, time acts strange at extreme speeds or gravity, but that's special. No, it's fundamental. Earth is the special case. Your everyday experience is the anomaly, not the rule. Space and time aren't a stage where events happen. They're active participants. They stretch, they compress, they rearrange cause and effect. And they do it without asking whether your brain finds it reasonable. NASA doesn't argue with this. It builds around it. Every interplanetary mission calculates trajectories not just through space, but through curved space-time. Gravity assists aren't slingshots in the cartoon sense. They're negotiated interactions with moving, massive bodies that reshape the path available to a spacecraft. Miss the geometry? Miss the planet. Now push further. Imagine falling toward a massive object. From far away, everything looks normal. But as gravity deepens, time slows relative to the outside universe. Signals take longer to escape. Motion becomes asymmetry. From the outside, you appear to freeze. From your perspective, nothing special happens. Both descriptions are correct. This isn't paradox. It's relativity refusing to grant you a single true frame. Your intuition demands one story. Physics allows many, as long as measurement agrees. This is the intellectual pressure point. You don't get to ask what really happens. You get to ask, what does each observer measure? And that distinction dismantles common sense. There is no master clock ticking behind the universe. No cosmic referee keeping time fairly. Each path through space-time writes its own version of duration. Now ask yourself the question people avoid. If time can slow, stretch, and diverge, what happens when curvature becomes extreme? What happens when space bends so aggressively that future directions collapse? You already know the answer's name. You just don't yet know what it costs. Black holes aren't special because they're dense. They're special because space-time there stops behaving like a negotiable surface and starts acting like a trap. Not for matter, for causality. Every step toward them reduces your available futures, not emotionally, geometrically. The universe edits your options until all roads point inward, and still, locally, everything feels fine. This is the part your intuition cannot survive. Catastrophe without drama, doom without force, oblivion enforced, not by violence, but by structure. You want to imagine a boundary where physics shouts danger. There isn't one. The equations stay calm, the clocks stay honest. Only later do you realize the math has removed escape entirely. And if that unsettles you, it should. Because the same rules that slow satellites' clocks and keep GPS honest are the ones that allow horizons, time dilation, and causal traps. There is no separate extreme physics. There is only physics, applied without mercy. You don't live in a universe that bends occasionally. You live in one that bends always, and you just happen to occupy a quiet patch. For now, you've been treating black holes like exotic monsters at the edge of reality. They're not. They're what space-time does when you stop pretending intuition matters. By the time you're near a black hole, every comforting concept you rely on, distance, direction, duration, has already failed. Not violently, casually. The equations never panic. They just keep returning answers your brain doesn't like. Start with the horizon. People call it a point of no return, which sounds dramatic and wrong in equal measure. There's no wall, no surface, no detectable marker. Cross it and nothing locally changes. That should bother you. Because boundaries without signals are an insult to human reasoning, we expect transitions to announce themselves. Physics doesn't share that expectation. From far away, the story looks theatrical. Objects slow, signals stretch. Time appears to grind toward a halt. Light reddens, fades, vanishes. You interpret that as freezing. That's not what's happening. You're watching space-time run out of routes. Near the horizon, the geometry tilts so aggressively that all future directed paths lead inward, not because something is pulling harder, but because outward stops being a future option. Direction itself gets redefined. Inside, down isn't a place. It's a moment. This is where language breaks. And when language breaks, intuition follows. You want to ask, what happens inside? Physics replies, that question assumes structure. I can't guarantee. Einstein's equations still apply there. They remain obedient, elegant, merciless. But they point toward a region where curvature becomes infinite, where density, according to the math, diverges without bound. That's not a physical description. It's a confession. Physics uses infinities the way doctors use fevers, as symptoms, not explanations. They tell you something deeper is wrong with the framework. And this is where Einstein lost his monopoly. General relativity governs the large. Quantum mechanics governs the small. Both are spectacularly successful. Both refuse to cooperate in extreme environments. Black holes are where that refusal becomes unavoidable. At the center, whatever center even means anymore, the equations predict a singularity, not a thing, a failure. A place where space-time itself stops being a meaningful concept. You can't point to it. You can't observe it. You can't test it. All you can do is acknowledge that your best theories stop speaking coherently. That's not mystery for mystery's sake. That's the edge of knowledge. And it gets worse. Black holes aren't just cosmic endpoints. They're thermodynamic objects. They have temperature. They emit radiation. Slowly, quietly, predictably. No imagination required. Just math surviving scrutiny. This radiation means black holes aren't eternal. They evaporate. Over timescales that dwarf civilizations, stars, even galaxies, but not infinity. That should destabilize you, because it means black holes forget. They lose mass, they lose energy. And according to our current understanding, they may lose information, not hidden, not scrambled, gone. Physics hates that. Information loss violates principles so fundamental that entire fields exist to avoid it. And yet, black holes seem to demand it. So now the question isn't what is inside a black hole, it's what does the universe allow to be erased? This isn't philosophical, it's institutional discomfort. NASA, particle physicists, cosmologists, all circling the same wound. Either information is preserved in ways we don't yet understand, or our understanding of reality is incomplete at a structural level. Pick one. Neither is comforting. Now widen the lens. Black holes aren't rare glitches. They're common. Every large galaxy hosts one at its center, including yours, including the Milky Way. Its mass sculpts stellar orbits thousands of light years out. That influence isn't violent, it's architectural. Black holes organize galaxies. They regulate star formation. They anchor structure. Without them, the universe would look radically different. So the very objects you were taught to fear as destroyers are, on cosmic scales, stabilizers. That inversion should feel disorienting, and it gets deeper. Early in the universe, density was extreme everywhere, not black hole extreme, but close enough to make space-time highly curved on all scales. Time, then, behaved nothing like it does now. Expansion wasn't motion through space. It was space itself changing. There was nowhere to go, only how to evolve. This is why cosmologists don't talk about the universe expanding into anything. That question assumes a background. There isn't one. Space is not inside something larger. It's the container and the content simultaneously. And gravity, geometry again, dictated how fast time unfolded as the universe cooled, diluted, and structured itself. Your existence depends on that sequence, not metaphorically, causally. Every atom in your body traces its history through regions where space-time curvature determined nuclear reactions, particle lifetimes, and cosmic chemistry. You're not in the universe, you're an outcome of its geometry. Understanding the universe, then, doesn't mean holding the right mental picture. It means accepting that reality runs on rules indifferent to your comfort. Black holes don't break physics. They expose where physics stops pretending. They're not lessons, they're audits. They tell you which ideas survive pressure and which collapse when space-time is allowed to behave honestly. And if that feels unsettling, good. Because the final mistake is thinking this knowledge makes you safer. It doesn't. It makes you smaller. You've been waiting for reassurance. You won't get it, because the final refrain says closing, closure, walks, breaks, pain, for what? You assume understanding the universe means taming it, naming it, rendering it familiar. That assumption dies here. Physics doesn't exist to make you feel oriented. It exists to describe what survives measurement. And what survives measurement is often hostile to human intuition. You live inside a narrow band of conditions where space looks flat, time feels steady, and cause follows effect politely. You confuse that local calm with universal order. It isn't. The universe doesn't scale smoothly with your expectations. It fractures them. At small scales, reality becomes probabilistic. At large scales, it becomes geometric. In between, where you live, you get a fragile illusion of solidity and flow. That illusion is temporary. Black holes are not cosmic villains. They're reminders. They show you what happens when space-time is allowed to operate without compromise. No cinematic drama, no moral framing, just consequences. And here's the part people avoid saying out loud. There is nothing special about your position in the universe. except that it's unusually forgiving. You are not centered. You're not timed correctly. You're not guaranteed coherence. Your clocks work because gravity here is weak. Your body functions because time flows at a manageable rate. Your thoughts feel sequential because space-time locally permits sequence. Change the environment, and those assumptions dissolve. This isn't hypothetical. It's already happening. Every second, the universe expands, not into space, as space. Distances stretch. Light loses energy. Galaxies drift beyond causal contact. Horizons form not around objects, but around eras. There are regions of the universe that will never affect you, not because they're far, but because time itself will not allow the interaction. That's not tragedy. That's geometry again. The same rules that create black hole horizons also create cosmic horizons. Limits on knowledge enforced not by ignorance, but by structure. You can't outrun them. You can't wait them out. You can't think your way past them. Understanding, then, is not possession. It's alignment. It's learning which questions remain meaningful under pressure. What is really happening often isn't one of them. What can be measured is. That's why Einstein matters. Not because he was right about everything, but because he allowed the universe to contradict him. His equations predicted realities he didn't like. He trusted them anyway. And the universe rewarded that humility with accuracy. Then it pushed further. It gave us black holes. It gave us expansion. It gave us time that bends, space that moves, and equations that admit their own limits. And it left us there. No final theory. No narrative closure. No guarantee that reality is comprehensible in total. That's not failure. That's the condition. You are not meant to master the universe. You are meant to survive inside it long enough to notice its rules. And notice this one carefully. The universe does not run on intuition. It runs on consistency. What survives is what fits the structure, not what feels right. Black holes don't care that sucking makes sense to you. Time dilation doesn't care that simultaneity feels obvious. Space-time doesn't care that you want a center, a direction, or a final explanation. Reality isn't built for narrative satisfaction. It's built for self-consistency. And you, brief, localized, temporary, are a pattern that happens to persist under current conditions. That's all. No insult intended, just accuracy. Cosmic humility isn't about feeling small. It's about stopping the demand that the universe explain itself on human terms. You don't need comfort from physics. You need clarity. Black holes clarified something essential, but the universe will follow its equations even when those equations unsettle you, even when they predict their own breakdown, even when they deny you intuition, imagery, or closure. Understanding doesn't make the universe gentler. It makes you quieter. And in that quiet, something rare happens. You stop asking what the universe is for and start asking what it allows. That's where real understanding begins. You have not enough humanizer words left. Upgrade your surfer plan.